Hi, we're the Husky steam engine team. I'm Alex Johnson.
And I'm Keenan Thungtrakul. I'm the team leader.
So our this was a picture of the desired product. Well, this is our finished product. We started by breaking it into two separate subassemblies. On the left, you can see we have what we called the base subassembly, which had the majority of the parts, and then on the right, we have the shaft subassembly that did the rotating.
There are multiple parts that had to be modeled separately and included in the main assembly because we wanted to simulate the engine in action using the manipulation tool in CATIA. So there are parts that are not part of any subassembly.
So we're going to start by discussing the base subassembly. Here's the ISO view of the completed base subassembly and the corresponding exploding view. Like I said, this is the one with the most parts, so it got a little bit messy right there. Um, so the first part was one I made is the cylinder. Basically, we just started off by I just started off by making a cylinder and I pocketed it and I cut out a flat side to the desired width. Actually, is how it was defined, and then I used some negative booleans or removal booleans to create the holes at those desired 19-degree angles. And here's another couple views of it showing the PCD is where the holes are placed, and you can see the different pockets. And on the right hand side, you can see all the holes that need to be made top and bottom in order to allow the screws to be put through it. The piece that went on top of that is the cylinder head, and so you can see those matching holes. And again, the 26 millimeter diameter PCD. All of our units are in millimeters. Um, honestly, it's just the hat that went on the cylinder. I used this, but I kind of created a profile, and then I used the shaft command to rotate it. That's how it started. The valve chamber is another one I worked on. Keenan helped me quite a bit with figuring out how to present this. But basically, it's another one where I started off with the cylinder, a padded cylinder, and then another padded cylinder on the bottom, and created a counterbore hole going up the middle. Off to the side, there's a hole running through it that's also counterbored, as you can see. There's This one was kind of complicated to create because it is also two parts, as you can maybe see in the upper right hand picture. It's gold, and there's a kind of a, I guess, gray finish to another one, so it gave us a hint that there were two parts. So here's another part. It's kind of anticlimactic. This one was pretty simple, as you can see.
So this part was probably the most complex in the entire Husky steam engine. It's the cylinder plate. This plate had a 26 millimeter diameter pitch circle with 8 holes that will allow screws to be put in to hold the cylinder in place. And then there are 6 other holes here for the pillars, which hold up the steam engine itself and makes room for the piston rod to slide in and out during operation. And then there's this hole here which the valve chamber connects to, and then this main hole here that the cylinder slides into. Now in the main provided drawings, these fillets here were not clearly defined. So in this drawing we had to assume that this radius here was the same as these fillets here, just to keep things simple, and then everything else was filleted to 0.1 millimeters as per the drawing specification. Then you can see the 26 diameter pitch circle that the 8 holes are evenly spaced on. So now we have the base plate. This is what the entire engine sits upon. Now these countersunk holes, their outside diameter and angle had to be estimated based on the provided drawings because they were not specified. So we had to use our best judgment there to make this plate. There are 6 holes for the pillars and then 2 for each of the bearing plates, which supports the shaft. And now we have the engine's bearing plates. There are 2 of these, one here and one here. These are what holds the shaft in place as it's rotating. There is a countersunk hole up here. Now this hole is to be drilled after assembling everything. There wasn't anything slid into it in the provided drawings, so we're not exactly sure what the purpose of that hole is, but it's there, so it had to be included. Now this is the little bronze bearing that is right here and here. That bearing is press fitted in, and then the hole that is drilled into the top of the bearing plate goes all the way through. Now we have the exhaust port cover. This cover goes on top, goes over those 3 holes that were drilled into the side of the cylinder to direct the exhaust, steam exhaust from the engine out back. This particular part had a 105-degree gap, so I had to do a bit of math there with the shaft command in order to determine how that was going to look. We also had this smokestack thing here that was located off to the side at an angle of 37.5 degrees. It wasn't clear whether or not this was drilled into the center or a little offset from the center, so I had to assume it was in the center, which is usually where it is. And then here you can see the section view as to how that smokestack is positioned relative to the main casing.
Here we got the extremely complicated pillars. And you can see these things they're just chunks of brass that are holding up the cylinder plate from the base plate. Not much going into them, to be honest. Just a tube that has some holes drilled in the side.
So now we have the shaft subassembly. So this is the part of the engine that rotates when in motion. So it consists of 6 parts: a flywheel, a cam, a crankshaft, a crank handle, and then a washer and a screw to hold the piston rod in place. So this is the main flywheel. This is what the engine drives. If it were attached to, say, a model train, this flywheel would be one of the drive wheels of the train and would propel it forward. So here it's just a little red wheel that is going to be rotating in place since the engine is just sitting upon a base. And here we have the cam. This particular part drives the valve rod, which acts as an intake/exhaust valve for the engine, kind of like in a 4-stroke piston cylinder engine. This one was a bit hard to model because of this part right here. I assumed that it was a tangency all the way through, down through here, and then we've got this circular profile here, which was mirrored across the symmetry plane of the cam part. And then we have the crankshaft. It's just a really simple shaft with a slight end to it. That's where the crank handle would mount. And then the cam would slide in first, and then the flywheel would come in second. And then we have the crank handle. This is what the piston rod will drive when the engine is in operation. This part here connects to the piston rod with the screw going in to secure it, and then this is where the crankshaft would connect to the handle. So there are other parts, as I've said earlier, that are not part of any subassembly due to the fact that we wanted to be able to simulate the engine in action using Mach kinematics, the manipulation tool. So we're going to go through those parts now. They are the valve rod, the valve spring, the piston rod and pin, and the piston head.
Here we have the valve rod. The valve rod, basically, I did a pad command for the top portion. As you can see, there's two portions. There's kind of the main segment up here, and there's a cap on the bottom. For the cap on the bottom, I created a profile, and I used the shaft command to create it. Those two, if this was actually to be created, those would need to be designed or manufactured such that there's a press fit joint between the cap and main shaft. In addition to that, we have the valve spring. Again, to not a terribly complicated part when I figured out how to do that slinky assignment. Basically, I started with a circular profile and I used the helix and I just spiraled it up with matching the pitch and total height.
So here we have the piston rod. This is what is going to be driving the crank shaft, which drives the main engine shaft. It looks like that radial engine articulated rod in that we have a larger circle here and a smaller circle here. This angle here, 12 degrees, had to be estimated, and this length here had to be estimated because the drawings were not clear as to those specifications. And then these pads, and then this was padded up and then mirrored over to get this part here. And then we have the piston pin, which is to be press fitted in when assembling the piston. It's just a simple rod of either aluminum, steel, or iron. There's nothing really complicated about it. It's just a simple rod.
Here we have the piston head, and this is the quintessential example of them not giving us enough information. There's not really any information as to the location where this hole went, and or even if it went all the way through. So there was a lot of trial and error that went into seeing how it worked with a lot of other parts. Of course, hindsight being 2020, it's not that difficult of a part to look back on. It's just basically I started again. I took the approach of creating a basic outline using the shaft command and putting a counter bore through the middle, and that was about it. All right, and that's basically our design.
Mm-hmm.